In this video, I will be explaining nodal analysis, which is a common technique used for analyzing electrical circuits. This technique allows us to determine the voltage at different nodes in a circuit by applying Kirchhoff's current law and Ohm's law. So to define nodal analysis, we first need to define what a node is. A node is a point in a circuit where two or more components are connected. So for example, in this circuit, we have V2. Both resistors are connected to the same point, so this point is referred to as a node. Now, nodal analysis works by selecting one node as the reference node, which is also called the ground node, and this node is assigned a value of 0 volts. And all the other voltages at the different nodes are measured relative to this reference node. By applying Kirchhoff's current law and using Ohm's law, we can create equations that allow for us to solve for the unknown voltages. Nodal analysis is fully based on Kirchhoff's current law, which states that the total current of entering a node must equal the total current leaving the node. For example, in this diagram here, we have I1 entering the node, and we have I2 and I3 exiting the node. So that means the sum of I2 and I3 need to be equal to I1, which is shown correctly in this diagram as I1 is entering with a current of 11 amps, I2 is exiting with 7 amps, and I3 is exiting with 4 amps. 7 added to 4 is 11 amps. Now the steps of nodal analysis are as follows. First, we need to identify all the nodes in the circuit. So every point where there's multiple components connected to the same point, that's referred to as a node. Then we choose the reference node, which is usually chosen at the bottom here, at the ground symbol, and then we assign voltages to each node. So we assign V1, V2, we assign V1, V2, and V3, and then we use Kirchhoff's current law at each node. We then use Ohm's law to express each current as in terms of voltage and resistance. Since resistance is already known from the circuit, we can put these equations in terms of V and solve for V. Now we will look at a practice question. So here's a simple circuit we will be working on for the practice question. So we have here a 10 volt battery, a 2 kilo ohm resistor, a 4 kilo ohm resistor, and they're both connected to the same point, which is labeled V1. So first we need to find the voltage across each component, divide them by each resistor, and use Kirchhoff's current law. So the voltage across the R1 here will be equal to V1 minus the 10 volts. And the voltage across R2, since the only voltage is being applied, since R2 is connected to ground, the only voltage being applied is V1. So the voltage across R2 is just V1. Is just equal to V1. Now we divide each of them by their corresponding resistance, and we add them, and because we're using Kirchhoff's current law here, the sum of those currents will be equal to 0. So we use V1 minus 10 over the 2 kilo ohms, so 2000, plus V1 over 4000 is equal to 0. Now we multiply top and bottom by 2. V1 minus 10. And because there's a 0 on the other side, we can just cancel the denominator. So we expand this to V1 minus 20 plus V1 is equal to 0. Carry the 2 to the other side, and because they're both V1, we can add them. So 3V1 is equal to 20. So that means V1 is equal to 20 over 3 volts, which is equal to 6.67 volts. So this video Just to summarize, we first looked at the theory of how to do nodal analysis, and now we see how it applies to a simple circuit here.